Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Zainal and my metric number is CN190082. Today I would like to present about my final year project on simulation study of elbow characteristic at various operating procedure. My supervisor's name is Technologist Dr. Norizal bin Mustafa. First, I will go through about the abstract, which is this study was conducted to compare the 90-degree elbow characteristic under several operating procedure, which is the operating procedure is from 10 bar to 16 bar. There are four different operating procedure that will be tested to the three different of wall thickness of piping. Piping system was created in SolidWorks, then transferred to the Ansys software in order to obtain the result of simulation testing. Okay. From this analysis, it is confirmed that the elbow pipe was the highest pressure point located for flow distribution along the pipe. Besides, the simulation proved that it is the best way to examine the specification of material and pressure than experimental method, which cause safety effect if failed. And as an introduction, elbows are commonly utilized in industrial installation to guide flow and offer the flexibility to the system, which means elbow allow us to redirect our direction of the pipeline system. Depends on the structural plan. Besides, elbow are considered critical pressurized point in the piping system due to their stress intensification and the effect of band curvature. This is because they are more susceptible to various corrosion failure types and straight pipes. Late discovery of elbow damage can result in variety of hazardous and emergency circumstances, including environmental disaster, pollution, and serious threat to human life. Next, there are three articles that have been chosen for this study, which is quite related to the study. The first one is from Antonio, which is in 2020. The method is simulation performed under the same condition for standard and vortex manifolds and plug T's to compare the associated mechanism and relative reduction in erosion. The objective of his study is to compare the mechanics involved in the relative erosion reduction to illustrate the nature of the erosive process in each pipe fitting. Then lastly is to predict the penetration ratio and validate it using experimental data. The finding of his study is the dramatic decrease in permeability across the swirl chamber of manifold. Then the second article, which is from Mutana in 2021, the method that used is the completeness assessment of damaged pipeline bands made with the steel API 5LX52 was performed with numerical modeling framework using finite element method and finite element analysis. The objective of the study is the limit pressure calculation using modified codes and FA results. Secondly, the nodes failure assessment diagram for the straight pipe and pipe bands with corrosion defects. And the finding is there is a great settlement among the ring strain price required the use of the Goodall method for calculation. Lastly, the third article is finite element analysis was used to study the burst pressure of corroded and uncorroded pipe, which is written by Mondal in 2022. The objective is to investigate the corroded and uncorroded using finite element analysis. Secondly, to identify the parameters affecting the burst pressure of the pipe. The finding for this study is the burst pressure is lower for a pipe band with a larger bend angle. the burst pressure is reduced by the corrosion defect at the pipe bend more than the burst pressure of corroded straight pipeline with same corrosion dimension. Next, we will go through the methodology, which is the first one starting from the research background, which is done in semester 1. During this section, I've gathered all the articles related to the studies in order to gain data and information related for my study. After that, I proceed my studies with preparing the 3D model of A53 B carbon steel, which is the same material as in plant Biodiesel UTHM, and according to the pipeline schedule of 1.5 inch which selected by my supervisors. Then I set the drawing with 3 different wall thickness, which is the first one is 2.77 mm, second one is 3.68 mm, and last one is 5.8 mm. After finishing the 3D model, which is drawn in SolidWorks, I proceed my step with the analysis testing in Ansys software. Then, if the analysis software get done correctly, I will move to the next stage, which is gathering data for Ansys. If not, I will run the simulation again and gain the data again from the beginning. After finish analyze the data, I will start writing the thesis and complete it until the end, which is submission of the final year project thesis. Before that, the flow analysis testing will be using the pressure condition of 10 bar, 12 bar, 14 bar and 16 bar. Next, we will go through the result and discussion. The first one is pressure distribution. The graph on the left is the maximum pressure distribution, meanwhile the right is minimum pressure distributed. In this graph, we can see that between the 3 wall thickness, the value of maximum and minimum is increased. Besides, the value is also increased between each of specified bar, which means the higher the pressure tested, then the higher pressure distributed in pipelines. Then velocity distribution, same as above. The left one is maximum velocity distribution and the right one is minimum velocity distribution. The value shows decrease between the 3 wall thickness, and it also shows decrease between the pressure tested of each wall thickness. Next, static structural test. In this test, the data that I have required was divided by 3, which is the first one is total deformation. In the graph of total deformation, in this graph, both graph of total deformation, which is for maximum and minimum, shows increase between the wall thickness, and it is also show increase between each of wall thickness to the specified bar. In this case, it's same as the pressure distribution, which is the higher the pressure tested, or the higher the value, or the thicker the wall thickness, the total deformation also increase. Next, equivalent elastic strain, same as total deformation. which is increased between the wall thickness, and it is also increased between the specified tested pressure. And lastly, the equivalent stress also increase between the wall thickness and specified bar. These three result of static structure test shows that the piping specification is not suitable for this specified pressure, which means based on the result they obtained, it is confirmed that the specification of the piping is not compatible to the specified pressure tested in this simulation study. This is because the specified pressure tested is labeled as high pressure steam, which specification of piping in order to withstand the pressure. Lastly, as a conclusion, the pressure drop proved after hitting the first elbow from the fire tube boiler. This is because elbows were used to change the direction of piping, which caused internal friction of fluid within the pipeline. Depends on the design. Besides, material selection and piping specification also were important factors that needed to be considered in order to design piping system. This is because to decrease cost on material and contribute to losses in terms of profit due to over-design. The outcome of the study, which the specification of the piping selected were inaccurate for operating condition parameters, which is 10, 12, 14 and 16 bar of pressure. This operating pressure were too high for the specification of elbow tested. That's all from me. Thank you.